In 9a, we are asked to use logarithmic differentiation to find y prime, or dy dx, to find the derivative. Alright, so what we have is a function raised to a function power, and probably the most common way of differentiating something like this is to use the method of logarithmic differentiation. So we begin by taking the natural logarithm of each side. And now the natural logarithm of x to the sine x can be rewritten as sine of x times the natural logarithm of x, just using one of those rules of exponents. Now we differentiate. We use implicit differentiation. So the derivative of the left side is 1 over y prime, or dy dx if you prefer that notation. Now over here, to find the derivative, we're going to need to use the product rule, because we have two functions and the operation between the two functions is multiplication. So we will have the sine of x times the derivative of the natural logarithm of x, that's 1 over x, plus the derivative of the sine of x, that would be cosine of x, times the natural logarithm of x. And we can multiply each side by y. And I'm going to clean this up a little bit as I go. And of course we need to rewrite that y as x sine x, or x to the sine x power. In 9b, we are asked to use logarithmic differentiation to find y prime, where y equals cosine of x raised to the sine of x power. So we start out by taking the natural logarithm of each side. Then we use implicit differentiation. So over on the left side we get 1 over y prime. Let's see, actually before we differentiate this side, I probably ought to rewrite it like this. Sine of x times the natural log of the cosine of x. Now, when we differentiate it, we'll be using the product rule. So we'll have sine of x times the derivative of the natural log of cosine of x. That's going to be 1 over cosine x times the derivative of cosine of x, which is negative sine of x. Then we will have the derivative of the sine of x, which is cosine x, times the natural logarithm of cosine x. And that will probably clean up a little bit. Let's see. That's negative sine squared of x over cosine of x. Another way you could write this is to write it as, well, let's see, sine of x over cosine of x is tangent of x. So you could write this as negative tangent x times sine x. Maybe I'll do that on the next line. So again, what I was saying is sine of x times 1 over cosine of x, that is tangent x. So this is negative tangent x sine x plus cosine x natural log of cosine x. So let's multiply each side by y. That'll make 1 over there. and y over here. So y prime is equal to, let's call that cosine of x, natural log of cosine of x, minus tangent x sine x times y, which is cosine x to the sine x power.